Hello everyone, this is Simon Caris bringing you 2019 Science Paper 1 Physics and talking of the last session of the part, which is section C, which has two options to choose questions. So I am going to take you in this tutorial, and I believe it's going to be of a very big help to you, mostly to the GCE people, and secondly even to the guys who will be writing in November, the grade 12s. This will be very helpful. So just be patient with me and stay blessed as you watch me. Now, without wasting much of the time, let's look into the tutorial. Today's tutorial we are going to look at science, which is physics paper 1. Then we all know that physics has 3 sections. It has section A, section B, and section C. So I want us to pay particular attention even as I am going to take you into physics. So we all know that under section C, you are given only 2 options to choose, to pick 2 answers. You are given 3 questions and to choose only 2 answers. So today we're just going to deal with 2019. Is it 2019? Then it is section C. Then C2 reads 2 lamps S and T of resistance 200 ohms and 300 ohms respectively are connected in series with a 240 volts mains as shown in figure C2 below. So we are able to see the diagram there playing on the screen. It is a connection in electricity. So the first thing we should notice is before we do anything, we should first look at the diagram and identify the connection, the type of connection. So we know that we only have 2 types of connections in electricity. We have in series and in parallel. So if we are to look at this diagram, we know that it's a connection done in series. So the first question reads A. It says calculate the current at point V. So we are asked to calculate the current. Before we do anything, we must play along with formulas here for us to know exactly how to go about it. So I am going to write this triangle. It's going to help us know our formula. So I'm going to write something like this. Then here we know it's voltage. Then here we've got current. Then here we've got the resistance. So we have something like this. We have there voltage, we have current, then we have resistance. So the question is asking us to find the current at point V there. So we're going to make I the subject of the formula. So it will be current is equals to voltage over resistance. So now we know the voltage you have been given. We know the resistance. How do we know the resistors? We find the resistors by adding. When it's in series, we add. So the formula for finding resistors, because there is no way we can just solve this without knowing the resistors. So what we're going to do is we're going to say RT, which is total resistance, it is equals to, since the connection is in series, it is equals to R1 plus R2 here. So it is equals to R1 plus R2. So when we look at the diagram, what is R1? R1 is 200. So RT is equals to 200 ohms plus what is R3? What is R2? R2 is 300 ohms. So it's 300 ohms. So the total resistance is equals to, we're going to add on our calculator there. When you look at 200 plus 300, that's 500. So it's 500 ohms. Then we have found our total resistance. Therefore, having done like this, we are able now to calculate the current now. So now that we have our voltage, which is 240. So we're going to say current is equals to voltage, it's 240 divided by the resistance. The total resistance we have found to be 500. So I'm going to write my 500 like this. Then using our calculator, we are going to say current is equals to, then we are going to divide. So the answer is 0.48. We should be familiar with the units. So it is 0.48 amps. 0.48 amps. So the next question, it is asking us to find the potential difference across lamp S. The potential difference. Please note that potential difference, it is the same as voltage. So whenever you hear they are just asking you to calculate the potential difference, just know it is, they just want you to calculate the voltage at S. So at lamp S. So now I'm going to say PD, which is potential difference, it is the same as voltage. So we are calculating voltage. What is the formula for voltage? We are going to look at our triangle here. So voltage, it is equals to current. It is equals to current times resistance. So I'm going to say V is equals to total is equals to current times resistance. So it will be like this. So what is our voltage? We should note that the voltage in series, it is the same. The voltage in series does not change. The voltage in parallel can be different, but the voltage in series, it is the same. Yes. So we are going to continue like this. So we are saying we are calculating the voltage here. So we are saying V is equals to, what is our current? Our current at the current we have found already to be 0.48 amps. So I'm going to say 0.48 amps times what is our resistance? Our resistance, since they are saying calculate the potential difference across lamp S. So we are only focusing on lamp S. So on lamp S, it's saying 200 ohms. So I'm going to say 200 ohms. So it will be like this, 200 ohms. So when I calculate on my calculator, just very fast, then I say 0.48 times 200, the answer will be 96. So meaning our voltage is equals to 96. Therefore, we're going to say, since they are saying potential difference, to show that we know it all, we're going to say therefore P D is equals to 96 voltage, since the potential difference is the same as the voltage. So our units will be voltage. Then we have calculated, we have 3 marks as we are talking. So it says, I'm going to question B. Draw a circuit diagram showing resistors S and T connected in parallel. So we all know that the drawing we are dealing with, it was a series drawing. So now we are looking at something which is drawn in parallel. So what we are going to do is we're going to get our rule, and for us students, I advise very much that we use a pencil to draw, because this is in an examination room. You might lose marks for drawing using a pen. So I am drawing. We have something like this. We are drawing now. We have something like this. Should be bigger for all of us to see. I have something like this. Then I'll have here, here, then here, like this. Then I'll have something like this. Then I'll have something like this. Like this. Then I join nicely. I join nicely here. Okay. Then we'll have something like this. This is our lamp. This is our lamp. So we know that the first one was 200. It was lamp S. So this is lamp. Okay, I'm going to say S. Then this is our T. Then we know this is our lamp. So they want us to draw, and we have drawn. So they're saying draw a circuit diagram showing resistor S and T connected in parallel. So we can see the connection here. It's in parallel. But the one we have, the drawing, it shows that it's in series. So here we have shown. But we are forgetting one thing. We should not forget the voltage, the battery. We should not forget. So it's 240 volts. So it's 240 volts. Then we have drawn. So now, the next question says CI. It says current through lamp S and lamp T. Calculate the current using the diagram in 2B. So we are using the diagram which you have drawn. So this is the 2B. Now 2B. Yeah, 2B. So now C says using the diagram in 2B, calculate the current through lamp S and lamp T. So we are calculating the current now. So we're going to start our calculations now. So now that I have drawn calculations, I can do them here. So now our calculations, they are between S and T. So meaning we're going to find two currents, then we'll find the total current. So I'm going to say this is our, we remember the formula, we remember how we do it, we remember the diagram. So it's voltage is equals to current multiplied by resistor. So we are finding the current. So the current, I'm going to say current is equals to, we are calculating the current. It is equals to voltage over resistor. So we have something like this. So now, looking at what we have just drawn, we've drawn something like this. So to calculate the current, we know here it is 200 ohms. Here it's 300 ohms. We have something like this. So we are calculating the current through lamp S and lamp T. So what we are doing here basically is we are calculating first the current for S. So we are calculating current for S, for lamp S. So how do we calculate the current for lamp S? We say current is equals to voltage over resistor. So what is our voltage? The voltage, it is 240. So we're going to say 240 divided by, since they are saying for lamp S, so meaning what we are saying what is S? S on our diagram here, we know it's 200. So I'm going to write my 200. Then when we punch on our calculator, when we say 240 divided by 200, we're going to have something like current is equals to 1.2 amps. This is our current. Now we are done for S. So now the question says current through lamp S and lamp T. So for lamp T, I'm going to say lamp T is the one we are calculating. So we are saying we are applying the very same formula. So we're saying current is equals to V over R. So we know our voltage. The voltage is the same. So we are saying the voltage is 240 divided by, across T, the lamp T, it is 300 ohms. That's our resistor. So we are putting our resistor to be as 300 ohms. So now I'm going to say current. When I punch on the calculator, it will be 240 divided by 300. I'm going to have something like 0.8 amps. So this is what I'm going to have. I'll have something like this. Then I have calculated the current through lamp S and lamp T. So now, question CI. So this one we are doing it is question C, Roman numeral 1. So for us to find Roman numeral 2, they are asking us to calculate something like resistor. What is the resistance of the circuit? So we know the formula. The formula is it is like this. We don't have to forget the triangle because physics is all about calculations. And once you forget the calculations, then you are gone. So it's V over I, then I have my R. So I am finding the total resistance of the circuit. So when finding the total resistance, I'm going to say R T, which is total resistance, is equals to, we consider how this is connected. We have agreed that our connection, it is in parallel. This is a connection in parallel. And when a connection is done in parallel, what we do is we say RT is equals to R1 times R2 over R1 plus R2. This is how we find. So now, what is our R1? Our R1, it is 200 ohms. So I am going to write total resistance is equals to R1, it is 200 ohms, 200 ohms times R2, which is lamp T, it is 300 ohms. So I am going to say over, what is my R1 down there? My R1 still will be 200. Then here plus. Then my R2 here, it is 300. So I'm going to calculate. When you calculate 200 times 300, you have something like 60,000. So to clarify, let me check. So it's 200 times 300. I have something like 60,000. So here RT is equals to 60,000 over, what is 200 plus 300? 200 plus 300. The answer is 500. 500. So I have something like this, 500. So for us to continue to find our total resistance, I'm going to say RT is equals to 60,000 divided by 500. It is equals to 120. Since the unity for the SI unity for resistor, it is ohms. I have something like this. Then I have found my total resistance. So this says, give 2 reasons why lamps are preferred when it comes to the connection, like are preferred connected in parallel in homes. Give 2 reasons why lamps are preferably connected in parallel in homes. The first thing to consider is, have a picture of a home. When you connect the connections in series, it will mean when you switch one bulb, the entire house will go off. But when you connect in parallel, it simply means when you switch one bulb in the sitting room, in the bedroom, the bulb will be on. So it is for bulbs to work independently, for lamps to work independently. Then again, the other answer for D, it is when you are connecting the connections in a home, when you are connecting in series, we are able to see that from the start, when we calculated the connections in series, we were able to see that we had something, our current was 0.48 amps. But here, when we look at the connections in parallel, we have something like 0.8 amps plus 1.2. So our total current in parallel, we have something like, when we add 0.8 amps plus 1.2 amps, we have something like 2 amps. This is our total amps. So the point I am trying to make is connections in parallel. In parallel, we have the current is bigger, while in the connection in series, the current is small. So that is the other answer for D2, for D. Yeah. So now I'm going to the next question here. I'm going to the next question. So the next question says, The next question says, below a diagram showing a bowling ball as it rolls down an incline for 5.0 seconds before reaching the horizontal ground. The diagram, the changes in gravitational potential energy, which is GPE, gravitational potential energy of the bowling ball as it rolls down to the horizontal ground, are shown in the table C3.2 below. So this is the diagram. Yes, there we are having we have time elapsed in seconds. Then we have got on top, this is the time on top, on the x-axis. It's 0, 1, 2, 3, 4, 5. Then the potential energy, it is in joules. Of course, we know energy or power, it is measured in joules, the SI unit. So we have got 9 there on the Y, we have got 7.2, we have got 5.4, we have 3.6, we have got 1.8, then we have got 0. So now, the question is it question what? Question A, C3A. C3A says, state the law of energy conservation. It's 1 mark. So, meaning you shouldn't write something very bigger. But it's to write something like, I'm going to write here. So, we know that we've got different types of energy. We've got solar energy, hydroelectric power energy, we've got nuclear energy, and we all know about energy. So now they are asking us to state the law of energy conservation. In short, they are trying to make us join and to make us define what is the definition for energy for conservation. So I'm going direct to the point. The law of energy conservation, it states that energy can neither be destroyed nor created, but rather it can be changed from one form to another. For example, a still car, a car which is standing still, which is not moving anywhere, it possesses their potential energy. Now, potential energy, this is the energy the body possesses by virtue of its positioning, its position. But kinetic energy, we know they are trying to tell us about some kinetic energy. It's any moving object possesses kinetic energy. For example, a wheelbarrow, a car, a bicycle, all those stuffs, they possess kinetic energy. Where kinetic energy is applied, hydroelectric power, for those propellers to when water enters into the machines and it causes the water causing the machine to propel. That's the potential energy changing into kinetic energy. So in this, we should know that energy cannot be destroyed. No. Energy cannot be created. No. Then we are done. We have the 1 mark. Alright, so it's time elapsed in seconds. Then here is the table. So here, to show us everything, we have something like 0 here. Then we have 1, we have 2, we have 3, we have 4, we have 5. Then here we have 9. Then here we have 7.2. Then here we have 5.4. Then there we have 3.4. Is it 3.6? We have 3.6. Then we have 1.8. And finally, we have a 0 here. So they are asking us, the question is saying, using the values in table 6.3 to draw a graph of potential energy against time. So before we draw the graph, the first thing we should consider is coming up with the name of the graph. What's the name of the graph you are drawing? So the name of the graph comes from the question. So the question saying draw the graph of potential energy. So we can say here is the graph. Here is the graph. In an examination room, you'll be provided the graph. So the graph says potential energy. So we can say the graph against the potential energy, or the graph of potential energy. So here I'm saying the graph of potential energy. I have something like this, the graph of potential energy. So after coming up with the graph, let's look at what we are given. We are given the time and we are given the potential energy. So before we even draw the graph, the second thing we should put in our mind is coming up with a suitable scale. A scale which is going to help us to draw a graph. So our graph should be clear and it should be seen. Everything should be seen on our graph. So for us to do this, our time, we know it is our x-axis. So I'm going to say scale. So I'll start from here. So I'll say scale. This is my scale. So on my x-axis, I'm going to say x-axis. I'm going to say 2 centimeter to represent 2 units. 2 centimeter to represent 2 units. So it's 2 centimeters representing 2 units. Then y, it's, if I want, I can also say 2 centimeter to represent 2 units. It doesn't really matter as long as the scale is balancing to make the graph to be seen. So now, having looked at what we are given here, this is what we are given. It's something like this. So here, we are drawing the graph. So now, on my y, I'm going to say 2 centimeter to represent 2. We can just be looking for a proper scale. It cannot be like this since I'm roughly doing this. So now we are starting to draw our graph. So we have a line like this. We have a line like this. We have a line like this, then, and also a line in my x. So the second thing also is to always remember that this is our y and this is our x. So now, having done this, we are going to say this is where our 0 is. So on my y, I have I'm going to say this is my time. On my x, I'm going to say this is I'm going to say this is my time. So it will be time in seconds. Then here I'm going to say it is a graph. I'm going to say potential energy in joules, something like this. Then I'm showing it to my examiner that I know it. Oh, Then the second thing is I'm going to start now plotting here. I'm going to start plotting. So before I start plotting, since I'm saying 2 centimeter on my x, this is my x. So this box, it is 2 centimeter. 2 centimeter is going to represent 2 units. So I can still make assumption. So I'll say 4 centimeter to represent 1 unit. So 4 centimeter to represent 1 unit. I have changed here, so it's no longer the same. It's 4 centimeter to represent 1 unit. So here, from here up to here, it's 4. So I'm going to say, since here it's 0, so I'm going to have something like 1. I'm going to have something like having looked at everything here, so I'm going to say 1, 2, 3, 4, meaning the scale is not balancing, so I make amendments. So I say 2 centimeter to represent 1. So it will be like something like this. 1, 2, 3, 4, 5, 6, 7, or even up to 8. Now on my y, I have something like 4 centimeter to represent 4 centimeter. I am making amendments now. I just look for a scale which can work for me. It's very important. So on my y, I'm going to say 4 centimeter is going to represent 2 units. So I'm going to say here, so it will start 2, 4, 6, then I have 8, then I have 10 here. Then it has balanced. Having done like this, then it is balanced. So now I'm going to say I start plotting now for us to finish everything. So I'm going to say 0,9. So where is 0,9? 9 is somewhere here. So since this is 8, this is 9. So I'm going to write using a pencil. So 9 will be somewhere here. This is where my 9 will be. So I'm going to say 0,9 is somewhere. So I go on my what's this? On my rule. So 0,9. So it's on the x-axis, 0,9 is here. Then for me to, I'm going to also do something like, I go to the next step. I'm plotting now. So I'm going to go on my x, and I'm going to say 1 over 7.2. So it's 1, 7.2. So I know here it's 6, meaning here it's 7. So I'm going to count these small boxes. I'm going to calculate. I'm going to find exactly where the 7. Since this is 6, so meaning 7 is here, this line. So here, this is where 7 is. So now 7.2 is somewhere here. 7.2. Then 2,5.4. So I go on 2. This is 2, 5.4. So since this is so now it's 2,5.4. So I know 5 is here. Since this is 4, meaning 5 is here. Then there's 6, 7, then there's 8. So meaning 5 will be somewhere here. I'm writing using a pencil. So meaning 5 is here. So it's saying 2 on my x, it's 2. Then on my y, it should be something like 5.4. So 5.1, 0.2, 0.3, 0.4. So 5.4 is somewhere here. So it is somewhere here, 5.4. Then I'm going on the next one. The next one says 3, comma, is it 3? I go on 3 on my x. Then they are saying 3. Then I say 3.6. So I know this is 2. Meaning 3 is somewhere here. So what do? I say 3.6. So from this same line, I go here. Then I say 1, 2, 3, 4, 5, 6. So meaning 3.6 is somewhere here. So where it is, I do like this. Then I go on 4. Then on 4, I do 4 on my x, then 1.8 on my y. So it's 4. So my ruler is here. So 4, this is 4 down here. This is the 4 here. This is the 4 we have seen it. This is the 4. So now I do 4, 1.8. So 1 is here. 1 is here. So I come here on this line where there's 1. So here there's 1. So I say 1.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. So 1.8 is somewhere here where I am plotting, joining, writing the dot. So it's 1 point. So now I'm going to say 5.0. So I know 5 is here. This is where the 5 is. So now on my x, on my y, it's on my x I go on 5. Then on my y I do like this. So this is where my 5 is. So now there's a need for us to come up with a straight line. You can see that this is a straight line. Even if I put my ruler here, I use it to join, you can see this is a straight line. So meaning whatever I should come up with, I should make sure that I use my hands so very well that I draw. So meaning I'm going to have something like this. So it's something like this. I'm going to have something like this. So I'm going to have, we should make sure that it's a straight line and that all the points are meeting. This is a straight line where all the points are meeting. All the points are meeting. But for you, since this is a sample, we should have something very clear. So now, having done that, we are going to our next question. So the next question is requesting us to, it's saying, calculate the height of the inclined plane when the potential energy was 91 joule if the mass of the ball was 900 grams. So now, I think for C, let us ignore it since we're only dealing with the graph. Since this is our graph we have drawn, so D says, using the graph, estimate the kinetic energy of the bowling ball at time 2.5 seconds. So we are using the graph. The key point is using the graph, estimate the kinetic energy of the bowling ball at time. So Roman numeral 1, the time in seconds, it is 2.5 seconds. So meaning we are going on 2.5. 2.5, exactly where it's 2.5. So here, if we're able to see, this is where my 2 is. So 2.5, it is somewhere here. So 2.1, 0.2, 0.3, 0.4, 0.5. So 2.5 is somewhere here. So I'm going to use my ruler to measure exactly where the 2.5 is, and I'm going to use a ruler. I'm going to put it like this. Then it's going to go up, meeting this line. So I'm going to draw using my pen because I want everything to be seen. Since this is my 2 point, this is my 2.5. Okay, so it is this line which is 2.5. Okay, so now the next thing I'm going to do is where it has met from, I'm going to draw a line. Then that will be my answer. So I have something like 4 here. Here it's 4. Here it's 4. 4.1, 0.2, 0.3, 0.4, 0.5, 0.6. 2, 3, 4, 5, 6. So I have 4.6. So I'm going to say 2.5. It is giving me 4.6. I have something like this. So now then 4.0 seconds. 4.0 seconds. It is 4.0 seconds. It is equals to. I'm going to use my graph again. So I'm going exactly where there is 4. Here, this is where there is 4. So it's 4.0, meaning it's just the same as 4. So I'm going to draw a line until where it is meeting the long line here, the one we have plotted. So it will be from here. I have something like this. I'm now using a pen because I want things to be seen. So I have something like this. Something like this. Okay, this is it. Then where everything has met here, I take note. I should be thorough. I should be clear enough here. So I draw something like this. I draw something like this for us to see properly. So now, having done like that, I go on to here. It's 1 point what? Since this is 1, this is 1 here. I had written 1 using the pencil because of it wasn't put here according to our scale. So now I'm going to say 1. I count 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8. So I've got something like 1.8. So I'm going to say 1.8. Having done like this, then I can go back to C and calculate the height of the inclined plane when the potential energy was 90 joule if the mass of the ball was 900. So having done like this question we can solve. I can even solve using the back of the graph. Now that we are done with the graph, you have seen everything. So this is how. The only challenge which I had was coming up with the scale. That's the only challenge which I had. Now that I came up with a proper scale, even if it was a struggle. So now we are solving the question C. So C says, calculate the height of the inclined plane. So we can all see the diagram there. I think it's displaying the diagram of the height. So now what we do is we look at what we are given. So we are finding the height. So we come up with the data. We are correcting data together. So the height, there is a question mark. But let's look at what we are given. We are given the potential energy, which is P E. We are given, what is our potential energy? They are saying it is 9 joule. So potential energy is 9 joule. Now, looking at what we are given also, we are also given the mass. And the mass is given in 900 grams. So what do we do for us to easily come up with a formula? The data is important. So we are saying that this 900 which we are given, so I'm going to write somewhere like this. We're given the 900 as our mass. So since we are converting this 900 into kg from grams to kg. When we are converting, we always remember that you divide by 1000 because kilo means 1000. So we want to convert from grams to kilograms. So kilo is 1000. So I'm going to say divided by 1000. So when you punch on your calculator, you have something like 900 divided by 1000, you have 0.9. So meaning it will be equals to 0.9 kilojoule. Is that okay? So now I know that my mass here is equals to 0.9 kilojoule. Having done everything like this, we will be able now to come up with a formula. So the formula for calculating potential energy, it is PE is equals to mass times gravitational force times height. This is our formula, because we have our mass, we have our PG, our PE, we don't have height. So there's no need for us to make H the subject of the formula. What we're just going to do is we're going to say PE. What is our PE? Our PE is 9 joule. So I'm going to say PE is 9 joule. It is equals to, what is our mass? Our mass we have found to be 0.9 kilojoule times the height. What is our height? The height we are not given. It's the one we are looking for. So height, I'm going to just write H. It's the one we are looking for. So now, having done everything, when you multiply, since when you multiply 0.9, I've made a mistake. What is our gravitational force? Our gravitational force, our G, it is equals to 10 newtons per kg, per kilojoule. Or yes, per kilojoule. 10 newtons per kilojoule. So meaning I'm going to say, I am sorry people, so I'm going to say 9 joule is equals to 0.9 kg times, what is our gravitational force? It is 10 kilojoule times, what is our height? We don't know. So we are writing just H. So I am going to say, what is 0.9 times 10? So it is 0.9 times 10. So I have something like 9. So here I have, it is equals to 9 just. 9H. We are finding the H here. So it will be equals to. Then here I have the 9 joule. Of course, the joule and the joule will cancel, the K and the K will cancel, all that. So we're going to divide, since this is 9 divided by this, I'm going to divide both sides by 9, because I'm going to divide both sides by 9, this 9, because I want to make h, the subject of the formula, or the value of h. So I'm going to say over 9 over 9. Of course, something like that. So I'm going to say, we are rushing to the end. So now check this jaw, since it has cancelled, and this jaw, and so the jaws cancelled already, so I made a mistake. So it will be 9 just like this over 9. This jaw is not supposed to be here because it was a mistake. So I'm going to say this into this, it is 1. So meaning I'll remain with it. What is 1 into h? It's h. So meaning I'll have something like h. Then this into this, I'll have 1. 9 into 9, it's 1. So meaning 1 is equals to h. Then having done so, then it is done. Wow, thank you so very much for watching the tutorial. This is all I had for you, my friends, my boys, my girls, ladies and gentlemen, the GCE candidates. This is what I had for you. Thank you so much for watching.